Welcome to the lecture on binomial probability distributions. With binomial probability distributions, your data needs to be dichotomous, have a fixed number of trials, probability is consistent between all trials, and also all trials are independent. To use a binomial distribution, you must have dichotomous outcomes for your trials. You can make almost anything into dichotomous outcomes. In this particular situation, we have a company that is looking at 34 employees and their typing speed of words per minute. If they type above, in this particular instance, we have 60 or above words per minute is a failure, below 60 is a success. So the probability of being below 60 words per minute is 0.25, which means the probability of being at 60 or above is 0.75. When you use a binomial distribution, you need to have a fixed number of trials. So if there are 34 people that you are looking at, your fixed number of trials needs to be 34. Don't change it. Keep it at 34 because the probability that you determine is only applicable to 34 trials. Just like you cannot change the number of trials, you also cannot change the probability of success at each trial. Every single one of these individuals, the probability of them typing less than 60 words per minute is 0.25. That is a constant. It does not change. All the trials are independent. In other words, if one person types less than 60 words per minute, it does not impact whether or not another individual will also type less than 60 words per minute. Each individual types their words per minute and does not impact anyone else. There are two quick formulas that you need to know. The first one is the mean, or the most likely outcome. That is, multiply the number of trials by the probability of success at each trial. In this case, multiply 34 people by a probability of success of 0.25, which gives you the most likely outcome of 8. To get the variance, you multiply the number of trials by the probability of success at each trial. So that's 34 trials multiplied by 0.25, which is the probability of typing less than 60 words per minute. Then you multiply that by 1 minus 0.25, which gives you a product of 6.375. If you take the square root of the variance, you'll get the standard deviation of 2.52. But remember, this is not normally distributed, so we can't use the empirical rule with that standard deviation. That standard deviation is purely saying this is the average difference that each observation is from the mean. They were supposed to do better than what they did previously. So you can use the formula equals binom.dist to determine the probability of them doing better than their first attempt. This would mean that 7 or less of the 34 employees